Hey everyone, and welcome to this session, the first session of this TechTrain evening around building chat applications or ChatGPT applications with custom data or company data. My name is Geert Baeke. I work for Cronos. I'm also a Microsoft MVP, focusing strongly on everything which is Azure related. One of those things is, of course, everything which has to do with Azure OpenAI. Now I'm going to do the first session, which is a low-code approach to building these applications. And the next session will be done by Peter, who will look at doing more like a pro-code approach, where you need to build custom solutions. Now, we all, of course, have seen let's say, the success of an application like ChatGPT. A couple of months ago, of course, we all got introduced to it, and of course, many people who are in the field, they know quite well what went before that. But for most people in the industry and also for consumers, ChatGPT was an interesting new development. And of course, we're talking here about these big, large language models, which have been trained on massive amounts of data and which are very good at producing, let's say, coherent text. Might not always be correct what is said, but it always looks great or looks quite coherent when you get a result. And of course, these models are evolving today. They're not just text-based anymore. These solutions are becoming multimodal. What you see here, you have a photo with gaming characters. You can ask ChatGPT, hey, what characters do you see in this photo? Or the other way around, you can start asking to create photos, or with advanced data analysis, try and solve more complex questions. Now, of course, although these systems are great, there are a couple of issues. For example, if you ask today, who is the King or Queen of England, and you ask it ChatGPT, for instance, it'll say something like this: I have a knowledge cutoff, and I don't know anything beyond September 2021. That's the day up until the model was trained, and all the content is from that time. Now, there are ways to solve this, and many different systems solve it in different ways. How ChatGPT, the application, is solving it is by introducing Bing browsing. And as a Plus subscriber, you can actually use this feature. If you don't want to pay, you can just use Bing Chat as well for free on the internet, because it does something quite similar. And what happens here when we ask the question, who's the King or Queen of England, a web search is done first. And they click a couple of links, they get the data, and then based on the data you get back from the internet, the question is solved, or a coherent answer is distilled from the search results, right? And this is something that we can use when we build our own applications as well. In general, when we have an application that works with our own custom data, we want to basically go to that custom data first, retrieve relevant pieces of information, and then form a hopefully coherent answer. And in general, that goes a little bit like this. You have all sorts of data sources, structured, semi-structured, unstructured data. And sometimes you know exactly what data you're working with, like maybe code, for instance, and you'd like to build an application, an LLM application that works with those data sources. And one of the ways in which to interact with the data is by creating a chat application. It's not the only type of LLM-based application you can create. For example, you can also use LLMs in more like workflow applications, and in certain steps of the workflow, use an LLM to extract data and things like that. But we're going to focus on chat-based applications. And in general, these applications work somewhat like this. First, you have to have a document store, and you have to load the documents in from some place. That could be SharePoint, could be a file share, could be anything. Could be an Azure storage account. Now, because an LLM needs the text to work with, you have to also extract the text from these documents. So you have to support specific document types, like a doc, docx, PowerPoint, PDFs, text files, HTML, and so on. Now, These documents could be quite large, and research shows that using these documents in their entirety is often not a good approach today. One of the reasons is, for example, that it could be hard to find relevant pieces of text when you need to add them to a query, but also because most LLMs are limited in the amount of data they can process in one request. And when you do requests to LLMs, it's always one request. You do a request, you get a response back, and there's no state being kept from the LLM's point of view. You have to keep the state client side. So we're going to split up these documents into splits or chunks or whatever you want to call them. And then we're going to store those splits into some form of database. Now, a very popular form of database is a vector store. That's not the only type of database you can use, but it's often used with these type of applications. With the vector store, you store the splits together with a numerical representation of the text that conveys also the meaning of the text. The semantics are preserved in some way. And that will allow us later to find relevant pieces of text that are relevant to the query we're asking, right? Then we come to indeed a third part. Once we have our splits into a vector store, we come to a third part, which is the retrieval part. The retrieval part takes a query of a user, a question. Could be an HR related question, like, for instance, what kind of company car can I get? Might be typical for Belgium then in that case, but okay. And then what will happen is that question, we will also create a numerical representation of that question. So we know what that question is about, and then compare it with what we have stored in the vector store, and find, hopefully, relevant pieces of text that have to do with company cars, and maybe get that from our HR policy. When we have found those relevant pieces of text, we're gonna bundle them up, take those texts, and then combine the text with the query in a bigger prompt that we send to the LLM. And you know prompts, when you ask a question to ChatGPT, that's a prompt that you're building. Now we build that prompt programmatically, so to speak, where we say, hey, here's the original question of the user, but please use the context provided below to provide your answer. And usually we also say, only use that context. Do not answer beyond the context. So this is basically what is going on, and we'll demonstrate this, in my case, with a low-code approach. Now, a word about those queries, as I said, or about the splits and the queries when we work with pieces of text, and this numerical representation I talked about. This numerical representation is just the list of floating point numbers, and we can call that a vector. Now, these vectors, they can be quite a long list of floating point numbers, depending on the way they are generated. In our case, you'll see that there are 1,536 floating point numbers in such a vector. Because it's difficult to comprehend this in a multidimensional space, let's think about a vector of 2 numbers. And we can then actually plot those vectors in a very simplified, oversimplified diagram that you see here, where we first represent the vector of our query. That's a couple of numbers generated based on the question that we have asked. And what we then are going to do is we're going to try and find vectors that are close to the query. So in this case, we might decide, hey, you know what, the green vectors, that's okay. The orange ones we're going to drop. And then we look up the texts that belong to the green vectors, and we stuff those texts in a prompt. Now, the way, of course, that you are going to calculate the distance between the vectors will depend a bit on the model you use and maybe the scenario and so on. Now, most of the time, what we're going to use in our case, we're going to use a general purpose way of defining or creating these vectors. And OpenAI, next to an LLM, so a large language model, also has embedding models. And an embedding model is nothing more than a system, in this case, that takes in some text as input and then generates this list of floating point numbers. And yeah, of course, there is a lot of complexity into building those kind of models. That's not what we're here for today. And then we get, in our case, these 1536 dimensions. And OpenAI recommends that you use as a distance metric cosine similarity. Now, in general, it doesn't really matter that much. You can discuss about how much it matters. What we will see is that the tools we're going to use, the no-code tools, will basically use these approaches automatically. So when we're using, for example, Azure OpenAI Add Your Data, well, cosine similarity is used in the background. There's nothing you have to do to calculate this similarity or to know about the vectors and how to calculate the similarities and so on. That's something that is done for you basically as a service provided by a vector database or some other kind of database. And it's important to realize that a vector database is not the only thing you need, or like it's the holy grail of building these applications. They work very well, but what we see today is that more and more we don't just do a vector search, we also do a full text search, combine the two into what we call a hybrid search. And that hybrid search, the results of those two searches are merged and then given back. So in that retrieval part that we talked about earlier, right? The retrieval part, there, when we do the query, we do this kind of hybrid search. It's of course up to the application developer or the citizen developer in a low-code approach to decide, am I going to use this or not? And with the Azure solution, it's just a drop-down that you select. Do you want to have vector only? Do you want to have full text only? Or do you want to have a combination of full text or free-form text search and vector search? And we see also today that most vendors of vector databases, they're also building in this hybrid search, text-based search capability in their solutions. Yeah, because it often gives good results. Now, before I'm going to show you how it works in Azure, I'm going to provide you with a little look under the hood in how this system works. So it's time for a short demo. Now, what I'm going to do here is I'm going to stop the presentation for a moment and minimize this. And I'm going to open a browser session for you. And let's put that here so it is also recorded. And what I will need here is actually a new session. What I need here is in my bookmarks. So I'll get to my bookmarks here and we'll get to the demos and open up the TechTrain demo. Let's open them all. I think we open up Azure here. I'm gonna just log in case I need to show you something. But what I want to show you is actually this here. What you see here is an application which is called Flowwise. Now, Flowwise is an application which is open source, has nothing to do with Azure, right? This runs in Azure, but is an open source application that runs in Azure. And it can use Azure components like Azure OpenAI. We'll talk about Azure OpenAI later. But I wanted to use this to give you some kind of a visual idea of the steps that we talked about earlier in the PowerPoint. And what's important to note here is that we first have, of course, the first step, where are our documents? In this case, I keep it simple. I'm saying there's going to be one PDF file. It's called Innovatech PDF, which is like an HR policy for a company. What I'm going to do is that file is going to be split into multiple pages. It's a PDF. We split it in multiple pages, but we also have combined it with a recursive character text splitter. I want to create splits or chunks of like 1,000 characters and have a chunk overlap of 200. So we typically have like, we create these blocks of text, but we want some overlap between the blocks so we don't lose meaning, so to speak. So that's the first part. I'm going to actually, where do my documents come from? The second part is then to put these documents into a vector store, a vector database. Now, the vector database here is an in-memory vector store, which is specific for this application. It actually uses LangChain under the hood, which is an open source library for developing these kinds of applications. And we put in our vector store the documents, but of course we need to also create that vector for each document. Now, a document here is a split, right? So a document is actually now a part of the original document. And to create the embeddings, to create the vectors, we can substitute those words. We're going to use an embedding model. And the embedding model is one that is hosted in Azure. So Azure hosts the OpenAI model as well that I talked about, and that will generate these 1536 different dimensions. So what actually goes on here is that we take all the chunks, we vectorize all the chunks with the embedding model, and what comes out is like an in-memory vector store that can then be used as a retriever. And now we're building the LLM application because you have the retriever now, right? Now we can build an LLM application that will use a language model. We're using GPT-4 here in Azure OpenAI, right? We also need a retriever that when we ask a question, we first try and retrieve the relevant documents. And then we say, okay, when I think I found the answer, this retrieval QA chain, as it's called, don't worry about the naming, is going to give me the answer from the document. Now, this application, I can try this application out directly in the browser, directly here in this system, or I can ask for, well, you know what, I'm going to share it on a URL, and I'm going to take this URL and bring that over here. And this also allows me to, let's say, enlarge this a little bit. And I did this not right, so let's go back and let's do a little bit of a zoom in here. Now, I have in my document something about these company cars. So if I'm asking here, what company car, and I have to, of course, type it correctly. Although small mistakes are okay. What company car can I get? What should happen here is that we retrieve relevant pieces of text from the document, and then the LLM answers based on that text. So he says, yes, we allow a couple of cars. These are all electrical vehicles because we don't support gasoline or diesel cars. And then some additional information. These models can be quite chatty, and they want to provide more info basically to the user. And here you also see that we are bringing in the pieces of text that were retrieved by the retriever. The retriever is going to retrieve a maximum, in this case, of 4 pieces of text. We get these 4 pieces of text. And I can click on this. To see really like more low-level content. This would not be for an end user, but this is indeed in the first piece of text that's delivered, we directly see already that it allowed cars are here in this. Now, as you can see, there are like new line characters in there. This is coming from the conversion of PDF to text and the way that the PDF converter here is working. But for a model like a GPT-4 model, having those new line characters in there is not an issue. So that's great. We have our system here. But the question is, can we peek a bit more under the hood? And the thing is, yes, we can. Here you see a trace of what we actually did here. And here you can see it maybe a little bit. What company car can I get is here in the list. And if you look a bit here in the details, and don't worry about all the details, it's not important to understand all the details. But what you see here is that my question, the question I asked is formatted in this way. This is the question. And then we have some prompt here. And then we actually get a response. And the response, as you can see here, the response is basically the text plus then a list of the source documents that are provided as well. Now this is the overall chain, but you can see here also the vector store retriever step. That's the actual retriever part. The LLM is not doing that, the application is doing that. The application is doing a query to the vector database, what company car can I get? Yeah, that's the query sent to the vector database. And the vector database then outputs a list of documents here. And I can already see that allowed cars is quite quickly, it's at the top of the output here. This output here is then put inside a stuff document chain. And here again, the question is repeated, what company car can I get? And then all that information that you see over here with the actual answer from the application. So this is only to show you that what happens under the hood is when I type my question, something is going to retrieve information from an external system, and it's going to then hand it over to the LLM application, and then the LLM application forms an answer. And that's the important thing to capture here. Now, it's important to know that what I've shown here is, of course, a look under the hood, without too many Azure components. There are two Azure components used here. That is the LLM, which is hosted in Azure, and that's the embedding model to create the vectors that's hosted in Azure. But all the rest is basically open source tooling. So what we want to do now is we want to see how can we build this in Azure, fully in Azure, and also combine this with some aspects in the Power Platform to build a similar solution. And as the, let's say, the cherry on top, we'll add this, gonna also embed the application in Teams, so we have a real application that users can work with. And of course, to realize this, we're going to have to use Azure OpenAI Service. We actually already used it in the previous demo, but that was just the LLM. But Azure OpenAI provides more. Now, first of all, what's Azure OpenAI Service? Azure OpenAI Service is just an Azure service that hosts the same OpenAI models, but in a region that you select. So I have deployed my models to the France Central region, so in Europe, and that's where the processing takes place. So that's important for customers who have like data residency requirements and so on. Some additional things you can do with Azure OpenAI is to host it in your own network and not make it available fully on the internet, for instance. Now, if you go to Azure OpenAI Service, I'll show it later, there's a feature which is called Bring Your Own Data. And we're going to use that to create a similar solution as the one you saw in that open source Flowwise application. You should be aware this Bring Your Own Data part is a preview today, right? So you can play around with it, test it, see what it does. It will soon, but I cannot define soon, be available, generally available, or might be generally available soon for use. In a moment we'll see this. So what do you need for this? As I said, of course, an Azure subscription, that's logical, but you need to have Azure OpenAI first of all. There's still a form you have to submit, a form you have to fill out before you get to use Azure OpenAI. So you can't just go in your subscription, let's create an Azure OpenAI instance. You first have to request access using a form. That usually goes relatively fast. What you don't need to do anymore today is ask access for GPT-4. There used to be a time where you needed to ask access to GPT-4 as well. That's now granted by default when you have access to OpenAI. Now, for a chat application, you need a chat model in this case. So you need a chat model deployed. And you see here in the screenshot, I've deployed a couple of models in France. That's a view of my France region. And one of the models there is GPT-4. But you can use other models. You can use the somewhat older but faster and cheaper GPT-3.5 Turbo. Or use GPT-4, which has a bit more capabilities in reasoning and forming better answers. Now, you also see there are a couple of models there with 16K and 32K. These are basically models that can work with larger chunks of data in one request. So if you do need to send more data to a model, you can up to, let's say in this case, 16,000 tokens and 32,000 tokens. We're going to use the normal GPT-4 model, which supports 8,192 tokens. Now, what's the process behind this application? Because we're going to demo it all the way. The process is you upload files or point to an existing storage account container. You cannot point today in this particular wizard. You cannot say, please go to a file share, or please go to my SharePoint, or please go to this website where there are documents. That doesn't work in the demo I'm going to show you. You always start from, if you start from scratch, you start from uploading files or pointing to an Azure storage account. Now, whatever you choose, your data will always end up in another Azure service, which is called Azure Cognitive Search. And of course, if you already have built indexes in that search applications, if you're already a user of that service, you're also able to use an existing Azure Cognitive Search index. And that might be, for instance, an index that contains SharePoint data, right? So that's something that you should realize. Azure Cognitive Search is at the heart of the solution. The retriever, the part of the retrieval process is controlled or is done by Azure Cognitive Search. Now, this solution today supports out-of-the-box common data types. So doc, PDF, PowerPoint, Markdown, text, HTML, that's all supported. No other ones are supported. That's something that might come in the future. Or maybe this is all you need. Or you convert everything from to text yourself. There are all kinds of solutions, of course, that you can take. Now, what are we going to use? We're going to combine two systems. One system in Azure, which is the Azure OpenAI or Azure AI Studio Chat Playground. That's the first block of the solution. And as you can see there, when you build your solution in there, there's a deploy to button. Well, one of the options to deploy to is to deploy to a Power Virtual Agents bot. Power Virtual Agents are not new. They exist already for a while. But what they did is, well, in the US today, so you have to have an environment in the US, these Power Virtual Agents bots, they support something which is called conversational boosting with an AI model behind the scenes. And that's what we're going to use in this solution. So we combine both Azure and the Power Platform to create this one solution here. And we're going to do that now and build an HR bot for Teams using these two solutions. And we'll use the same company document, HR document that I've alluded to before. So let's try and do this now in the following demo. So I'm going to close PowerPoint here and go back to my browser. And in the browser, I have here my Azure environment. I'm first going to show you the Azure OpenAI systems. So here you can see my Azure OpenAI services. I have several ones. The ones I'm going to use is the one in France Central. So that's something you create after you have been granted access. You can create such a resource in your subscription. In my case, I'm going to not go in detail here. In my case, I want to go directly to my deployed models. You do that via the Azure OpenAI Studio. So when I click on that, a separate interface opens that will be homed to the France Central region. And now I can control several OpenAI related aspects here. Well, these are my deployments. So I deployed a model with a deployment name called GPT-4, and that's actually the GPT-4 model that's behind it. I can make this or give this a different name. That's not an issue, right? This is a more recent version of the model, so from June, 13th of June. And also, and that's very important, there's also a capacity limit there. So this one supports 20,000 tokens per minute. If you have a multi-user application, this won't be enough. So you have to think about either asking for increased quota or maybe have less models that take up more of your quota and only have the model here that you need. In my case, for the demo, that's more than enough. For the rest, there's not that much to do for me. I just need this deployed model. Now we can go to what we call the chat playground. And in the chat playground, I'm going to switch to my GPT-4 model here. And in the chat playground, we can do a couple of things. Now, I think I don't have here an add your data is not added yet. So I'm going to go here to the system message and I'm going to first change that system message. The system message is a way to give, let's say, the chat application some form of identity. So I'm going to say you are an HR assistant for Innovatech, a high-tech company. Your name is Innova Bot. Yeah, That's my system message. This has nothing to do with bring your data. That is a feature of these models. When you set a system message, I can ask questions now. For example, who are you? And it should be able to answer that, hey, I am Innovabot, right? So that's fine. That's due to the system message. What we also want to do now is see what kind of questions can we ask. For example, if I ask, what company cars can I get? You will get an answer, but of course the answer will be very generic. It depends on the position and the company's rules, but it doesn't know the company's rules. So we need to fix this here. Well, we can now add our data. And I'm going to add a data source here. And as I explained, it can be an existing Azure Cognitive Search instance or blob storage or upload files. I'm not going to upload files. I already have my files or one file in blob storage. I'm just going to select the storage account. So if you know Azure, there are storage accounts and you can store files in there. So I have a storage account with this name. Within the storage account, there's a container, like a folder basically. I call this OpenAI or OAI, and I'm going to then select an existing Azure Cognitive Search resource. This wizard does not create an Azure Cognitive Search resource for you. I deployed one here, the basic SKU, which is around 70 euros. There's also a free one that you could actually use. I'm going to use a basic SKU resource here, and then provide an index name, because what will happen is this system will go to your storage account, will index the documents in there and put them in an index inside Azure Cognitive Search. So I'm going to call this TechTrain, but there's a conflict. I'm going to call this TechTrain 3 and then go to the indexer schedule and say to do it hourly. That's a nice feature of this system because Azure Cognitive Search has this capability of indexers and they can go, in this case, at an hourly rate, check what has changed in that storage account and update your index accordingly. Now, I talked about vector search before. Azure Cognitive Search is a somewhat older system, exists for a few years already, and vector search was never part of that. They've added it recently in preview and also added the capability here inside this wizard. And of course, to do vector search, I need an embedding model. And then acknowledge that this will cost me some money because Azure Cognitive Search plus creating embeddings, that has a cost. When I go to next now, I can then set my search type. And as we've discussed, you can either select for vector only, or you can say, no, I'm going to do hybrid, which is vector and keyword together, and then some re-ranking on top of that. There is also hybrid plus semantic, which is even a more costly one. That's not something I'm going to do today. Now, I would have liked to select this option, but sadly, when we are going to export this to Power Virtual Agents, well, vector search is not actually supported. So I'm going to say next here and just select the keyword search, sometimes also called simple search. In my scenario, that will work. And this is a limitation today of the previews. That limitation will be lifted later as well. And actually, I do believe it used to work before, but then it was retracted or somehow, I'm not sure. Anyway, that will come later. So I'm going to say next here and then do save and close. And now the ingestion will start and yeah, the indexing will take place. Now, let me go to my Azure Cognitive Search resources. So here I have mine, the one I'm using, ACS Geba. And what you'll see here is that there are several indexes. I have several indexes already, as you can see, from trying out a couple of things. Well, in my case, I have indeed HR index and TechTrain 2. And now we're busy with the TechTrain 3 index. I can already explain to you what's going on under the hood, because actually two indexes will be created. One index, which is called the name of your index -index, just contains your one document. In my case, there's only one document in the storage account. Now, that's your PDF, not broken up into smaller pieces. But the actual index we're going to use contains these splits. And in this case, from my rather short document, 3 splits were created. And this is going to be the actual index used for the retrieval part. Again, entirely built automatically by this wizard on a search resource. If you go to indexers, you'll see that there are indeed these indexers that run every couple of times, so every hour. Data sources, in this case, that's my storage account. And there is also a skill set involved. The skill set is actually doing something which is that breaking up into pieces. This is a skill set of the type a web API skill, and they're using a feature of the OpenAI APIs in Azure, which is a chunks API that can then create the chunks for you. So the chunking is done by Azure Cognitive Search as well, or the splitting into documents is done by Azure Cognitive Search. This is now finished. So if I try to repeat the question, what company cars can I get? I should now get what company cars can I get? When I ask this question, what should happen now is that there is a retrieval step taking place using that TechTrain tree index. And we see indeed that now we have that. This is in my document. It says indeed that we provide only 4 types of models, quite nice, and no gasoline or diesel cars. They're not allowed. This thing also comes with references, so it can give me a reference to the actual content, right? This is a citation. This is not the whole document. This is a part of the document. But that's great. This works. Now, if we ask a question here, for example, who is the King of England? Let me go back to that original thing on the slide. What you should see here is an answer that resembles something like this. I'm sorry, I don't know, because it's not in the data set. In advanced settings of the Add Your Data preview, this has changed a bit over time, there's a way to limit responses to your data content. And with the strictness set in the middle, and then retrieve maximum 5 documents, that's something that is typically going to prevent you from asking questions beyond the data set. Setting it too strict might not give you anything, so you have to be a bit, well, let's say experiment a bit with it. Usually this setting of 3 is okay. Now, this is not an application I can give to my end users. That's not something that works. So let me see then if we can deploy to a Power Virtual Agents bot. And yes, we can, but there's a caveat here, because this is only supported in the US, in an environment, a Power Platform environment in the US. And if my default environment is in the EU, clicking this button will actually result in a bot without the integration with this cognitive search solution. There's a way to solve this. If you click on this Continue Empower Virtual Agents, you actually get a create link. If you grab that link and substitute the default environment with the ID of your environment in the US, you'll be able to create the Power Virtual Agent bot in the US region. So I'm not gonna bother you with that complicated thing. I already did it in advance, and I'm using the index in that bot. It's the same cognitive search resource, but I'm using the index HR index in there. So that bot is already working, created, and it's using the HR index bot. Now, to actually show this, I have to go to another browser session here, and I'm going to ask for my Power VA environment here. So Power VA, and I have here, I think it's this one. It goes to Power Virtual Agents, and here we'll see that we get a view of, I think, let's return home. This could be an older instance, so let's return home to web Power VA Microsoft.com, and here I have my chatbots. And here's the Innovatech HR bot. So this was created using that link from the OpenAI Studio, and then of course substituting the correct environment ID here. So this ID I used there. So let's go to the bot. It would, if you would create a bot in the Europe region, it would look very similar, but what would be missing is this system topic. I'm not going to explain in detail how Power VA bots work, but the integration of Azure with Power VA and then GPT models is actually here in this conversational boosting topic. This conversational boosting topic is triggered on unknown intent. So if the bot doesn't know what to do, it'll go to GPT. We can show this because there's a topic which is called greeting, and that means that if we are saying hi to our bot or stuff like that, yeah, GPT is not used, then this message will be displayed. Hey, how can I help you today? Right? But whenever an intent is not found, then we will actually get this conversational boosting topic. Let's go back to it and look at it. So let's go to the system topic here and look at conversational boosting. And here we see the create generative answers, and there's a data sources link in here. Now, there are more data sources available. Actually, with Power VA, you can easily create a simple bot that answers questions based on, for example, searches you do in Bing, or public websites that you add, like your own website, and you add your website to this. And even SharePoint links, but I haven't tried that yet. What we are looking at here is this link with the Azure OpenAI services on your data feature. That was created automatically by clicking that button, basically, from the playground. When I go to the connection properties, you won't see that much. We see that we use the GPT-4 deployment, and the model data points to the HR index. So not the one I newly built, but actually the older one, which is exactly the same thing. It has the same content within it. So now we have to ask a question which is not matched by an intent. So normally, again, I'll do another thing. How am I evaluated? Sometimes here there are errors. I have to warn you. Sometimes you might get timeouts, or there's just something wrong. It is in preview, so you might see some errors here and there. He's sending it now, but indeed it's correct. He's giving me an answer using GPT. It also says it, surfaced using Azure OpenAI in the bottom. You can provide some feedback there, although I don't know exactly where the feedback goes. Well, let's say this. Okay, it's nice. And I have a reference also to the account. Now, of course, in this case, because our index is using storage-based storage account, the link goes to a storage account, PDF in a storage account. Now, I have to open it, of course, up to the public to get access to it. So if you work within your own, let's say, firewall, and these are documents that everyone can have access to, you could use this approach, right? And make this storage account only available from within your internal network. But of course, this now for the demo, I opened it up to the public internet, which is fine. This is a fake document. Now, again, this is not something that my users can use. So what we have done is, of course, we have set in the settings, we have configured the channel, the Teams channel, and then we published our bot to the system. So let's check this out, and let's go to Teams. This is exactly the same bot will be surfaced in there. I'm going to make it a little bit bigger so you can see it. You can already see the Innovatech HR bot, but I'm going to delete it, right? And in the list of apps, I have indeed the Innovatech HR bot that I can talk to. And of course, here I can now say, okay, I can say hi, for example. It should normally respond without doing any GPT stuff. I can ask, who are you? Well, we'll see if that is matched by an intent or not. In this case, it takes a bit longer, so that might be a GPT answer. Well, no, he doesn't really know that here. So that's something, these are things that you need to, let's say, refine. And basically, I would use an intent for this and then use an intent to answer, and not having to spend any tokens with the LLM to have it say, I'm the Innovatech HR bot. What company cars can I get? That should work. Company cars can I get? If I ask that, we should normally get a response back from the GPT model, if the underlying, let's say, systems all still work. And there you have it. We have a, let's say, quite short answer in this case. And if I click on the link, it's the same thing that goes to the actual HR document. Again, if you build your index using SharePoint documents, you could have a SharePoint link in here, and you would go to SharePoint. but the solution by default doesn't work with SharePoint, so that's something that would be an additional thing you would have to do. So basically that is the end-to-end solution. If you think about this solution, what we have done now is we have used Azure OpenAI, and we have used it together with the Power Platform. Now again, expect this to change in the coming weeks or months. They're still previews, but it does show you that with a low-code approach, you can build a, quite already a functional application and embed that within Teams and so on to easily surface these kind of applications to your users, their chat applications. Now, to wrap up, because I also want to give some time to the other speaker, of course, what we typically say is we always try to evaluate a low-code approach first, and I would also recommend that to see, hey, the application we're trying to build with these services, can we use a low-code approach just to avoid the fact that you have to write custom code. Of course, low-code means in this case you use the services as is. If you need to modify how things work a little bit, you can do that within this low-code solution. Like in the bot, you can work with intents and all other kinds of things using Power VA to let's say, steer the bot into a certain direction. And there's also ways to use Azure Cognitive Search indexes, for example, in a more clever way, writing your own chunkers, for instance, and stuff like that. But then we're not exactly in the low-code spheres anymore. What you have seen was a nice combination of both some Azure functionality, so the Azure OpenAI service, and then Power Platform, the Power Virtual Agents bot. And of course, what you have also seen is lots of previews. Again, I have no exact ETA on when they will be generally available, but remember, add your data, that's a preview feature. The vector search within Azure Cognitive Search is a preview feature as well. And Power Virtual Agents with conversational boosting is a preview feature that's only available in a US environment, a Power Platform environment, not in a EU environment today. But again, that should all change. So I hope you liked this session, that you see what you can do with a low-code approach. I suggest that we take a break now. I think we deserve that, and we can go and get some fries and have a drink. And then after the break, we'll get Peter on stage, and he'll talk about building more custom applications, code-based approaches, and why you would do that for these applications. Thanks.